All right, for number 9, we have some trigonometry that we need to work with here. And we're going to first look at which function is higher. You might be familiar with these functions. You should be. We looked at these before, but if not, you could graph them on your calculator. So let me show you that. And you do have to be careful. Well, this one, that was the right function anyway. So first of all, we don't have cosecant on our calculator, so we can rewrite this. So we'll do this in blue. So this is going to be y equals 2 over sine squared of x. And the red, the next one is fine. What I want you to realize here, we have to be careful how we type this in. So remember that this is equal to 2 over sine of x, the whole thing squared. But when you type these in a calculator, they don't have a squared like this. And they also always put, when you type in sine, they always start with a parenthesis. So to do this, we want to actually put a parenthesis before the sine, then do sine, the parenthesis will open, x, close that, and then do the squared. And that's how we're going to have to enter that in there if you just type it straight in. So I'm going to show you something else a little later that you can do, which maybe you'll just choose to do that way all the time. But here we have 2 divided by parenthesis, sine, it opens a parenthesis, so we're doing sine of x. We need to close that parenthesis, close the next parenthesis, and then we need to square that. So there is that function. We already have the negative sine of x. Let's go ahead and hit graph. We notice here that the blue function is always above the red function. So we can use that as we're going to find the area between the two curves. Also, we have pi over 4 and 2 pi over 4 are on the right side. It doesn't cross over any asymptotes. So we can be done here, and let's go back. And now we want to write the integral that we need to find the area under the curve. So the area is going to equal the integral of our top function, which is this 2 over sine squared of x, minus our lower function, which is the negative sine x. And this is all terms of dx. So there's the function we want to find, or the integral we want to find. So let's go ahead and plug that in. We can go to math and 9, and we're going from pi over 4 to 3 pi over 4. So we can type that in, pi over 4 and 3 pi over 4. Here's where we also need to be careful about plugging this in. So you can put 2 divided by, and we're going to have parentheses to go around sine of x. Then we have to come out here. Well, we have to close our parentheses again, and hit squared. And then if you keep pushing over, you'll see what we have there. But we still have to do the rest of our function. We have to subtract the negative sine x, which is actually the same as adding sine x, so plus sine of x. And we want to keep going and put that in terms of x, so dx. And we can hit enter, and we get the area is approximately equal to 5.414 units squared. The other thing I wanted to show you, I'm just going to do this integral one more time. We have the answer, but maybe you'll want to use this, the integral, and we still have to put pi over 4, so pi over 4 to 3 pi over 4. And once we're in here, we actually can put a fraction in here. So we can go, see right here in the green, it says fraction. So you can hit the green button, hit the fraction, and you can do a numerator over a denominator. So you can choose that. And now we can actually put in 2 over. We still have to do the sine squared the same way. So we're going to do parenthesis sine of x, close, that was the parenthesis after the x, here's the parenthesis after the sine, squared. Then we can come outside of our fraction, we're going to add sine of x. Close that parenthesis. Notice that big parenthesis that's there is for the integral and then dx, and you can hit enter. So same idea, but you can use the fraction and type it in there.